Hi everyone, this is Mel, and today we're gonna go through chapter summary of counting methods. This is math method of VCE subject, unit 1 and 2. Okay, so this chapter is about arrangement and combination. So these are two main things for this combination. These are two main things for this chapter, and we'll mention also the addition rule and multiplication rule, which corresponds to the word or and the word and. Okay, let's go through bit by bit. First of all, what's the addition rule? So if there are m choices for one option and n choices for another option, and two options cannot be both chosen, then there is a total of m plus n choices and is associated with a word or. So what I mean is, let's give a simple example. For example, we have a sport team which have boys and girls. For example, let's have boys for 5 and girls for 4. Okay, so 5 boys and 4 girls. So if there's a competition and we only choose one from the whole group, so one from the 9 students, then that's where the addition rule apply. So there are 5 plus 4 choices equal to 9 choices in total. And on the other side, if we look at what's the multiplication rule, it's a bit different. It's associated with and. So if there are m choices for the first stage and n choices for the second stage, then there is a total m times n choices for both stage. We also use the 5 boys and 4 girls example. If we want to choose 1 girl and 1 boy, so 2 people from the group, 1 girl and 1 boy, to do the competition, then we have 5 choices of boys and 4 choices of the girls. So that's 20 choices. That's the difference between or and the difference between addition rule and multiplication rule. So in the in your SAC, if you see wording questions with or in it, then maybe you should use plus. If you see and, you definitely will use multiply. Okay, that's the huge difference between there. And then for the factorial notation, so what's factorial? So n factorial, written as this, represents n times n minus 1 times n minus 2 times blah 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 times 2 times 1. So if we have 4 factorial, that means 4 times 3 times 2 times 1. So all the number from this number until 1, whole number, all the whole numbers, and then multiply them together. So what about 0 factorial? So 0 factorial is 1. Just remember it that way. Also 1 factorial is also 1. Let's move on. So arrangements. An arrangement or permutation is a group of objects such that the order of the objects are important. So the order is very important. It's all about how you arrange things, how you put things in order. Order is important. That is, the arrangement ABC is and CBA are different. So if you whether you put A first or C first, or even let's say BAC, they're all different. So there's a very common example. If you have, for example, 3 seats, and you have a person A, a person B, and a person C. So their sitting are very important. So if we have person A sitting in the front, and then B, and then C, so that is different from if another case, if you have C sitting front and then B and then A. So these are different. That's what permutation is about. And then the number of ways of arranging n objects in a row is the factorial of n. Let's see why. So let's also use this example. So 3 seats, 3 people. We choose 3 people into 3 seats. So for the first seat, there can be 3 choices. So whether we can choose A or B or C. So if one person is in there, for example A is in there, then we only left with 2 options. And that's a 2 there. And then the left one is only a 1. So if we choose B here, then C must be here. Okay. And if you know that, this is kind of an AND problem, so a multiplication problem. So you can see the seats, the first, second, and third seats at 3 stages. So that's why we use times over here. Okay, the number of ways of arranging n objects in group size of R. That's P n R, which we write it, which is equal to n factorial, and then divided by n minus R factorial, which is equal to n times n minus 1, and then until the last term, which is n minus R plus 1. So n minus R is the denominator, and then plus 1. So why is that? Let's try an example, a very simple one. So let's say P 4 2. That's equal to 4 factorial divided by 4 minus 2 is 2 factorial. And you see, if you write it out, 4 times 3 times 2 factorial divided by 2 factorial, which we can cancel the 2 factorial out, which the last term is on the numerator is 3, which is the 2 plus 1. n minus R is a 2 and plus 1 over here. And that's the 2 plus 1, which is 3 over here. Okay, that's why the last term is n minus R plus 1. Okay, now we're done with arrangements. Let's look at selections. So selections are like, you can think of it as a more generous way of arrangement. So we don't care about the order now. It's also named as combination. So whether the 3 people ABC sits in any of the seat does not matter. So the ABC is the same as CBA. So the order does not matter. Okay, the number of combinations of n object in a group size R, written as CNR. Sometimes you will see this, which also means the same. This is actually equal to the permutation divided by the R factorial. Why do we want to divide by the R factorial is that we do not care about the order. And the order which is related to R. So if we have, let's say, let's also use this one, so C33. If we have 3 people and 3 seats, we do not want the order, so we divide by the 3, which here represents the seat, the number of the seats. So an object, we have 3 people in a group of size of 3 seats. Or let's change another example. If we have 4 people in 3 seats, we only have 3 seats, but we have A, B, C, D. And that means N is equal to 4 and R is equal to 3. So we do not want order. We do not care about order. And that's why we divided by the R factorial over here. And after simplification, you will get something like this. So N factorial divided by R factorial times N minus R factorial, which this part, the blue part, is equal to NPR. And then we divide by R factorial. Okay, so for N objects, we have a equation over here. So if we choose from N object, we choose 0, plus from N object, choose 1, N choose 2, N choose N minus 1, and then until N choose N. It's actually equal to 2 to the power of N. When the combination problem involves restriction, so if we have some limit or conditions, other specific condition, we need to apply, then we deal with this first. For example, if we apply to the 3C problem, if, let's say, A and B are girl and C and D are boys. So if we want at least, let's don't say at least, let's say if we want 2 of them to be girls, and what's the combination? What's the groups of combination we can have? So that is a very specific restriction. So we deal with this kind of a restriction first. Okay, so probability for sample space with equal likely outcomes, the probability of an event is found by dividing the number of outcomes in the event by the total number of outcomes. So if we have equal likely outcomes, so each of the outcomes are equal likely to appear, then the probability of an event is found by dividing the number of outcomes. So the number of outcomes in the event divided by total number. And that's the proportion, or we call it probability. Yeah, that's it for today. So we talk about what's the addition rule, which refers to the or plus. Multiplication is the times and. And the arrangement, which we care about order. And the selection, which we do not care about order. We care about the groups, the combinations. Okay, that's it for today. Thanks for listening.